All right, 7-5, day 1, simplifying radical expressions. All right, so we have some key concepts. We've got a product property of square rooting, okay, where you can take a times b, you can separate them out into two separate square roots, and then the square root of 4 is 2, the square root of 16 is 4, and then you multiply those. And then quotient property of square rooting. All right, if you have something in the radical that you can simplify, you do so. Sometimes you can't simplify it into a whole number, so you leave it in fraction form, but it is simplified. So we take 100/4 and we bring that down to 10/2. All right, and well, actually, we took the square root of 100 and the square root of 4, and we got to 5. Okay, so let's talk about how we get a square root into simplest form. Okay, so you know you'll be in simplest form when the following 3 conditions are met. Following 3 conditions have to be met. Okay, so 1, your square root contains no perfect square factors other than 1. The square root contains no fraction. And there are no square roots in the denominator. All right? Your square roots can contain no fractions. The square root contains no perfect squares. And there are no square roots in your denominator. Okay, that is how you will know it's in the simplest form. And that is one of the biggest things that people are facing is, tell me to simplify more. Okay, well, you didn't simplify it enough, and here are your rules of why. Now, there we go. So, when you face, okay, like the square root of 2 times the square root of 3, well, you can multiply these together and you get the square root of 6. And we have 2 prime numbers, they can't be reduced anymore, and so the square root of 6 can't be reduced anymore. All right, something you'll see on your assignment, just saying. Also, what you need to know is that taking the square root of something and squaring something are opposites, and they cancel each other out. All right, so if you have the square root of x squared, well, we can cancel out the squaring and the square rooting, and that just equals x. Okay? So if you didn't practice your factor trees, we are going to get some practice with those today, okay, because they are definitely things you need to know. I want to go over one more thing that you will see on your assignment that we don't have an example of. We have one, but it's not exactly like it. So let me do one more thing. All right, so let's say you have 3 in the square root of 5. Well, we just went over up here, there can be no square roots in your denominators. Okay, but 5 is a prime number. If you take the square root of 5, you have a decimal. I told you can't do that. Well, based on this, okay, here's what we do. So we want to get this radical out of our denominator. So we're going to multiply it by the denominator. And what you do to the bottom, you have to do to the top, okay? So that gives me 3, the square root of 5, over, well, this is the square root of 5 squared. Well, I just told you they cancel each other out. So that gives me 3, the square root of 5, over 5. Okay, you'll see something like this on your assignment as well. All right, where you can't simplify this any further, but we still have to get rid of the radical in the denominator. And just multiply the denominator with that radical times top and bottom. Squaring and square rooting will cancel each other out. And you're just left with 3 times the square root of 5, all divided by 5. Okay. Another one you'll see in your assignment that I just wanted to go over for a minute. Now let's get into example 1. Simplifying square roots. Now, with our prime factorization trees, what we're trying to do, we call them trees because you get branches. Okay, and what you're looking for is the lowest prime number you can think of. Remember, prime numbers can only multiply by themselves and 1. They can't break down any further. So like 2, 3, 5, 7, 11, 13, so on and so forth. Okay, so the smallest one you can think of. Even if it's not the smallest one, you'll get all of your same prime factorizations. Your tree just may look a little different than someone else's. You'll end up with all the same numbers at the end of your branches, though. They just may be in a different order. So, 72. The lowest prime number that's obvious is 2. So, 72 divided by 2, well, let's see. 72 divided by 2 is 36. All right. Well, I can still even, so I can still divide it by 2. All right, 36 divided by 2, 18. All right, well, that gives me 2 times 9. And I can break down 9 as 3 times 3. Now, I could have divided this by 3 to begin with, and that would have given me 24, and I would have taken that 3 and 8, and then 2 and 4, and then 2 and 2. My end prime numbers, I still would have ended up with 3 2s and 2 3s. So let's go back, and we're going to make a bigger radical. And we're going to put all of our prime factors of 72 under this radical. So I've got 2 times 2 times 2 times 3 times 3. Okay, so the square root of. Now, when we were doing radicals, and we were trying to rationalize them, you learned about x to the 1/2 power is the square root of x, and we simply don't place the 2 there. It's a given, all right? So because that 2 is a given, what we're looking for is we're looking for pairs of 2. When we're square rooting, we're looking for pairs of 2 that we can pull out. So I got a pair of 2 here, and I got a pair of 2 of the same numbers here. So I can partner them up, and then I can pull them out, and here's why. So that is the square root of 2 squared times the square root of 2 times the square root of 3 squared. Well, we just talked about squaring and square rooting are opposites, so these can cancel. Anytime you cancel anything, whether it's numbers and letters, you bring them out first into the front, and then anything that's still under the exponent goes in the back. So we can pull out 2 times 3, and then we can't forget the square root of 2. Well, we can multiply 2 times 3, and that's 6, the square root of 2. And there's our answer. The simplified square root of 72 is 6, the square root of 2. Right. Let's go multiplying our square roots. All right. Now, 5 is a prime number, so we can't do anything with 5 right now. All right. But 48, all right, that is not a prime number. Okay, so I can do something with that. I'm going to bring this down, okay, because I don't want to lose it, so I'm going to bring that down in the square root of 5. I have to do something with it. I'm just not doing anything with it now. And then we've got, well, the lowest I can think that goes into 48 is 2, and that's 24. I can pull out another prime 2, 12. I can pull out another prime 2, that's 6. And then 6 breaks down into 2 times 3. All right. Oh, let me block that off. All right, so again, I'm going to have the square root of 5 times the square root of 2 times 2 times 2 times 2, 1, 2, 3, 4, 1, 2, 3, 4, times 3. Okay. Now again, we're going to partner off what we can match up because it's the square root of, so we're looking for pairs of 2's of the exact same thing. So we got 2 2's and we got 2 2's. Okay, we're going to pull those out. So that is, well, yeah, I'm going to pull them out. All right, because they eliminate each other. So I've got 2 times another 2. And then that is times the square root of 5 times the square root of 3. Now I can simplify that one more time. Now I just pulled that out because the square root of 2 squared, we've talked a couple times, we can cancel that out, and that gave me my 2, okay? And why is that true? Okay, well, the square root of 2 squared, that'd be the square root of 4, and the square root of 4 is 2. Hence why they cancel each other out. Now let's back to our problem. All right, 2 times 2 is 4. The square root of, well, 5 and 3 are under the radical. That is 15. All right, again, don't miss this original prime number that's under the radical, the square root of 5. We need to make sure we bring it down when we are mathing. All right, dividing square roots, okay? Now, when we are dividing square roots, first thing we're going to check is because both of these are under the radical, so I can make one big radical and go 24 divided by 3. First thing I'm going to check, can I divide the top by the bottom and get a whole number? If I can, cool. I've gotten rid of my fraction. I don't have to worry about anything on the bottom in my denominator. But if not, if the bottom doesn't evenly go into the top, I'm going to look to see if I can reduce that fraction and divide both the top and the bottom by the same number to get a smaller number. But thankfully, this does reduce down to the square root of 8. So again, my prime factorization tree, 2, 4, 2, 2. Okay, so we have got a square root of 2 times 2 times 2. Again, we're doing the square root of, so we look for our match sets. All right, so I can bring out 1, 2 times the square root of 2. Okay. And I pulled it out for this exact same reason, all right? So, you're going to go on the back, and we're going to deal with not just numbers, but we're going to deal with some variables, okay? Now, the variables, this isn't hard, so it's just going to take some time and involve some steps, okay? So, don't be scared by it, don't be overwhelmed, just take it one step at a time. Okay, so we're doing the square root of 525 x to the 4th, y to the 5th, z to the 5th. All right, so we're going to deal with our number first. We are going to our prime factorization tree because 525 is not a prime number. So the obvious prime number I can take out of this is 5. And 5 times 105. Still obvious, I can take out 5, okay, and that would be times 21. Now the lowest prime I can take out is 3, and then 7. All right, have my prime factorization tree. Now here's where people get a little overwhelmed. Don't, all right? I'm gonna make a really, really big radical symbol. Because what I wanna do is I'm actually going to expand these variables so we can do our match sets, okay? So I'm gonna go smallest to largest, so I've got 3 times, I got 1, 2 5s, 5 times 5, and then I have a 7 times 7. All right, well, how many x's? Well, x to the 4, so that's 4 x's. So I got 1x, 2x, 3x, 4. And I have 5 y's. 1 y, 2 y's, 3 y's, 4 y's, 5 y's. And I got 5 z's. 1z, 2z, 3z, 4z, 5z. All right, I expanded out. Yes, it's a little long and obnoxious. And it's okay. You're taking this one step at a time. Now that I have this whole thing expanded out, we're going to, because it's square roots, so we're going to see how many pairs of things we have. Well, we have a pair of 5s here. All right. And I've got a pair of x's. Then I got another pair of x's. What else I got? I got a pair of y's and another pair of y's. All right. And then I got a pair of z's and another pair of z's. Okay. So whatever I have a pair of, I'm going to pull it out. All right. So I have a pair of 5s. I have a pair of x's. I have a pair of x's. I have a pair of y's. I have a pair of y's. I have a pair of z's. And I have a pair of z's. All right. Now under my radical, well, let's pick up what we have. We got 3 times 7. All right. What else didn't match up? I got a y here. And then I got a z here. All right. So I can simplify this a little further. So 5. X times x is x squared. Y times y is y squared. Z times z is z squared. And we have the square root of 3 times 7 is 21 y z. Okay, so that was what we were able to pull out from our original square root problem and simplify it with our variables. Again, we all agreed that it wasn't a whole lot of difficulty. It was mainly just a lot writing out. So it did get a little overwhelming. That's okay. Take it one step at a time. Okay, I know you can do this. All right, real-world example. The real-world example of exponents almost always has to deal with finance or something to do with money, okay, business. Anything that you go into, you're going to want to be really good in finance and business because everything involves it. All right, so finance. We have got Sarah uses an online calculator to determine how much interest she would accrue in a savings account after 2 years. Okay, let's see what we got. She plans to invest $750. When we're investing, your initial investment is called your principal. Okay, so that's your P. And the calculator determines that she would have $780 after 2 years. Okay. So she can find the interest rate R. Interest rate is always R. The savings account, using this formula, you got R equals the square root of A divided by P. Okay, your ending amount is A, and then that's minus 1, where A is the amount after 2 years. Okay, you set that A is the amount after 2 years. And P is your initial investment. It is called P because that's your principal. And what are we looking for? We are looking for our interest rate of R. Okay. So let's fill in what we have. All right, A goes on top. All right, P goes on bottom. All right. Let's fill in this formula. So R equals the square root of, well, A is the amount after 2 years, so 780 is the amount after 2 years, divided by P. P is the initial investment. Your initial investment is $750 minus 1. Now, I was telling you when you have a fraction under the radical, first thing I always check is if the bottom will divide evenly to the top. Okay, well, 780 does not divide by 750 evenly. but I checked to see what the difference is. Well, the difference between 780 and 750 is, well, 30. So I'm going to check to see if 780 divides by 30 and if 750 divides by 30. All right, and as a matter of fact, they do divide evenly. So we're going to take the top and divide it by 30, and we're going to divide the bottom by 30. Okay, let's reduce this a little to make our math a little easier on us. So 780 divided by 30 is 26. 750 divided by 30 is 25, minus 1. All right, so we can separate this out to the square root of 26 over the square root of 25 minus 1. Well, the square root of 26 is not a perfect square, but square root of 25 is. Square root of 25 is 5, and then minus 1. All right, this is the one area where we're going to math with our square roots, because we're trying to find our interest rate. And interest rate is almost always in a percentage, so we're going to math, we're going to get our decimal, we're going to change it into a percent. Okay. I guess I got to turn it on. So first up, the square root of 26 divided by 5 minus 1. Okay. That equals approximately 0.019. All right. Now I want to get this into a percent. So approximately, well, to get from a decimal to percent, you move your decimal place 2 places to the right, and that would be 1.9%, and we want to round it to nearest to the nearest percent, so that would be 2%. So approximately 2%. All right, your assignment is in Alex. You need to deal with 80% accuracy. Make sure you use your notes and show your work. Good luck.